Replicated is a platform that lets SaaS vendors or software vendors ship on-prem installable versions of their product. You're writing your software, shipping it to the web, and shipping it to your multi-tenant SaaS version, and your enterprise customers need a version that runs behind their firewall. Often that's in AWS or GCP or some cloud provider. But Replicated adds all the functionality that you don't have to do when you're shipping to your multi-tenant SaaS provider around audit logging and SaaS and support bundles and entitlements and everything. So we deal with shipping off-the-shelf third-party software all the time. Some of our customers who use Replicated today, we work with their end customers a lot to help troubleshoot and get everything up and running and deal with the application lifecycle for off-the-shelf software. So Ship. We decided to create Ship recently. It's an open source product, and our goal was to reduce the operational overhead with maintaining off-the-shelf software when it's running in Kubernetes. To start, let's kind of talk about what off-the-shelf software is. It's really anything that your team didn't write and deployed to Kubernetes in this case. So it's open source, proprietary software. Think about it's easy to think about things like databases and components, but it also includes all the agents that you're running on your cluster. Any third-party software is off-the-shelf software. Examples of off-the-shelf software that you might be running in Kubernetes, there's a lot of it. These are just some things that I think we run a lot of this in our cluster. The thing about off-the-shelf software that's different than software you write is the one thing that you have to write and contribute to it is the config. And there's really two parts to the config. There's application config and the runtime config. Application config is often delivered in Kubernetes through config maps and environment variables, and this contains things like database connection strings and application keys for third-party services that you want to use. Then there's runtime config. And runtime config is the actual Kubernetes API. That's the replica count and security contexts and update strategy and ingress controllers and anything that pod disruption budgets, anything like this. And now operators and custom resource definitions are becoming really popular, and so there's a lot of that additional Kubernetes API that you need to think about. Splitting this up, if you're consuming third-party software, application config should be known by the application developer and whoever's packaging it up, right? I can't take Elasticsearch and just add a new environment variable in and expect Elasticsearch to change its behavior because I invented an environment variable. So the application developer can template that out. They can do whatever they want to deliver that down, and they can code. It's a finite set of information, of config. The runtime config is not finite, right? The Kubernetes API is constantly changing. People are running it in all sorts of different environments with all sorts of different operators and CRDs running. All of those options are really independent of how the off-the-shelf software runs. And you can even, as the cluster operator, choose to use the runtime config to change how you're delivering the application config. So if the application config is delivering something as a secret or a config map or a volume, you can actually change that to match your configuration that you need. How do people deploy off-the-shelf software to Kubernetes today? There's lots of different ways to do it. Most of them use templating. Helm is the most common way to deliver off-the-shelf software to Kubernetes. It's a great way to prototype an application. It's not really a great way to operationalize and run an application in production for many reasons. One of them, the one that I'm going to kind of talk about right now, is that Helm charts just aren't customizable enough to work in any environment. When you think about somebody who's packaging a Helm chart, they look at, here's everything that you should be able to configure. And it has the application config and, as you can see, part of the runtime config. They might say, here's environment variables, here's settings, here's secrets, here's the image and a pod label and the tag and a pull policy that you want, but you don't have access to anything to the right of that dotted line. You can't get into the additional runtime config of Kubernetes. So we can just run that. That'll solve all of the problems that we have, and we can run that. That'll work in our production environment. Yeah, probably not really. So what do people do? They end up having to fork a Helm chart. Or even worse than forking it, they'll copy it because the Helm charts repo right now has hundreds of charts in one place, and so you forking that's kind of difficult. So you end up copying it down, making all the changes you need to do it. And why? Why do you have to do that? Well, because like we talked about, all of the infrastructure that in the cloud, the environment that we want to run it on is a little bit different. But traditionally, that's been a challenge with software all along. Kubernetes has now created a standard interface, a standard API for how software should be able to interact with the runtime. So why doesn't Kubernetes actually solve this in this case? Well, Helm is actually kind of getting in the way of solving it. Helm only allows you to access the part that's templated. In this YAML over here, they have pod anti-affinity rules, and there's kind of 2 hard-coded pod anti-affinity rules that you can put into there, and you can't change that and do anything else you want to do. So you only can do whatever the chart maintainer wrote. You can't add anything in, you can't delete anything, you can't make any edits to something that's kind of non-standard in their mind. So coming back to this picture here, this is the ideal chart, the ideal configuration the Helm chart maintainer may think you want to run it, but realistically, this is how everybody's running them. You'll fork the Helm chart because you need to get stuff on the other side of that line. And you may have removed a pod label, add annotations, added a custom resource definition in, and that's actually how you're running Helm charts in production today. That's an example of one person running one Helm chart in one organization, but you're running many Helm charts, and there's lots of people running Helm charts, so everybody's doing the same stuff over and over again. And so everybody ends up forking them. Long-lived forks are bad. Long-lived forks are bad because they make a manual process. You have to go update them. You have to go reconcile all those differences in, and it's just by definition, it's toil. It's hard work. Manual, it causes problems. Things that we hear from people are, yeah, I had to fork that, I'll update it once in a while. Or, we'll check for updates on a regular set schedule, or like, why? It's working, I don't need to go change it, I don't need to update it. I think everybody here knows updating is important. It's how we get security updates, it's how we get features, it's how we get fixes into the application. So I'm gonna do a quick demo here of a little kind of tiny microsite that we just released recently called Cluster Scope. And what Cluster Scope is a command that you can run. You can just, it's a kubectl command to get pods. It specifically gets the image name and image tag and Docker pullable, the content addressable SHA from every image that's running in your cluster. You can run that. I'm actually not connected to a Kubernetes cluster here, so I have the output of one that I ran before. You paste it into here, and all we do is we go check all those images against whatever upstream registry that is, whether it's Docker Hub or Quay.io or GCR. As long as they're public, we'll go look at it, and we'll figure out how old those images are and show it to you. So in this example, this kubeflow is 82 versions out of date, and it's not a Helm chart, so it's the actual image itself. There's been 82 releases past that. TensorFlow, Mongo is 32 versions out of date. Just kind of calls you out if you don't realize how much third-party software you're running in your cluster and how out of date it is. It's just a good way to audit it and look at it, and then potentially bring it under management and get it updated and monitor it over time. So once you have all these problems and you have all these forked Helm charts, what do? How do we get them all to go back upstream, right? If the goal is to not fork a Helm chart, but you've already forked them and everybody's already forked them, how do we get everything back connected to upstream? Should we just make pull requests? Everybody make pull requests into the upstream Helm chart? Apparently that's what happened in Prometheus. For the Prometheus stable Helm chart's been around for 2 years. And it was in the incubator chart before, but it's been around for 2 years. There's been 129 commits, averaging 1 a week. 100 of those, we went through the whole list of 129 commits. 100 of those were just make this configurable in the Kubernetes API. 19 of them were actual updates, and 10 were chores like add me as a contributor or whatever. In the 2 years, that values YAML has gone from 415 lines of configuration items to 1,116 lines. And then you end up with over 10,000 lines of templated YAML, which is ridiculously hard to maintain. So how do we solve it in Helm without forking? We can add functionality to the Helm chart and pull requests to upstream, but should we? That's the question, right? Every template, every new configuration item we add in increases the complexity and reduces the maintainability of a Helm chart. So we should ask, is this runtime config? If it's application config, the chart maintainer or somebody will have done that, or you should do it if it's not. If it's runtime config, is it something that's applicable to 80% of cluster operators? If it's 80% of people are going to want that as a configuration item, sure, let's pull request that in, let's make it something that everybody has available. If it's not, it doesn't really make sense to have all that custom config everywhere. Helm, if anybody's actually used Helm before or written a Helm chart, one of the Helm templates is to YAML. And that just shows that that's a leaky abstraction that Helm has around the Kubernetes API. If you see this and it says like to YAML, you're literally passing Kubernetes runtime config in through Helm, who's just writing it right back out to the Kubernetes API. So we can look at a Helm chart. Just as an example, I have one here, the Memcache one. It's a really simple Helm chart. It actually has a service, a stateful set, and a pod disruption budget, 3 different configs. It's been around for a while. One of the things that I might want to do if I'm running Memcache is have an update strategy so I can control the rollout. I want so many replicas of this stateful set running, and I don't want them all going down at a certain time, or maybe I want to do a blue-green deployment of it. And just looking through here, it's a really small font. Just looking through here, there is no way to configure that in here. And if we actually look at the template in the stateful set, there is an update strategy key that can exist on a stateful set in Kubernetes YAML, and it's not in here. So because of that, if I need to change the update strategy in this chart, I have to fork the chart, I have to go add that in, I have to add it in as a value, I have to like write Go templates, I have to run my own chart, which is going to be really hard to maintain. Cool. So there's other examples besides just update strategy. You know, some charts put sensitive data in config maps, and that might not be compatible with the way that I want to deploy code. I can't include custom resources, pod security context, affinity and anti-affinity rules. Maybe I'm running all of my secrets in vaults, and I need to include an init container to get those loaded into the environment. Helm charts don't often have that because that's super specific to an environment. Tiller, that's just got thrown in here. So the Helm v3 is coming, and it's supposed to solve a lot of this. It removes Tiller. Supports custom config, Lua scripting. Like they say, it's going to support a DevOps workflow. Thing is, it doesn't actually exist yet. But Ship does today, and it doesn't have Tiller, and you don't have to fork charts, and it's compatible with Helm, custom config. It plugs into existing workflows, automates merging upstream. So again, what's Ship? Ship reduces the operational overhead of maintaining off-the-shelf applications in Kubernetes. It's actually all possible because of Kustomize. When Kustomize first launched, the README had, 1, 2, 3, 4, 5, here's how to run it. And 5 was optionally capture upstream, capture changes from upstream. So the user can periodically rebase their base to capture changes made in the upstream repository. And we kind of looked at that and realized, like, that's unique, that's compelling, that's the real value to us, one of the strongest selling reasons to use Kustomize. It actually creates a way to do a git merge conflict-free update process in off-the-shelf applications. So I never have to fork anymore because I can keep all my patches separate from the actual base. We like Kustomize a lot, so we made a website for it. And that was the first contribution we made. We've made other ones to actual code in the Kustomize project since. So, now when you think about how to run off-the-shelf software, you can actually think there's actually a life cycle that you can draw out, you can write, you can plan, you can code, you can use. And the life cycle Ship implements is you go through the first step. It's going to be the initial configuration of the application. And Ship has 3 modes. It's Ship init, Ship watch, and Ship update. The first mode is init. And that's normally a manual process. You want to run Ship init against some off-the-shelf software or a Helm chart, and then provide all the configuration. You'll iterate on it locally. You'll get it working. There's a lot of different config you have to do. You're learning a new piece of software. Once you have that done, you can deploy it. You can kubectl apply it, or you can check it into some automation tool that's going to get it all deployed, and that's great. Then, because of Kustomize and because bases and patches are being kept separate, Ship watch can run, and Ship watch will just periodically check the upstream and calculate a stable SHA from what is upstream, and when it detects it's changed, it's basically just going to exit with the status code of 0, so it's a building block. It lets you do whatever you want to do. So now we can watch, and if that upstream doesn't change for a year, it's fine. That process is a long-lived process. It's going to sit there and run. Once it exits, Ship has a third mode that it makes sense to put in after that mode, and that's Ship update. And update will keep all of your patches, your overlays, pull down the latest version of the upstream, run Kustomize, reapply them, and give you the output file. And then you can hook that into automation, redeploy it, and then go back to watching for upstream changes again. So now you can have a full automation pipeline with CI and CD around third-party software. So now don't fork those Helm charts. Instead, just patch them. The Helm charts aren't actually valid YAML, and as Jeff mentioned a little while ago, like Kustomize expects valid YAML coming in. And so what we do here is we say, like, take a Helm chart plus custom values that you provide. Ship can turn that into, using Helm template, it'll turn that into like raw Kubernetes YAML, call that the base, and then you create all the patches you want to on top of that, and now you have a deployable application. So you can unfork anything that you have forked, go back to the upstream, keep all the customizations, and now keeping it all updated. With no git merge conflicts, put it into a GitOps workflow. We think that's the best way to deploy to Kubernetes, or any other automation that you want. So let's do a demo here. Let's do a Helm install with that custom requirement. We'll do the memcache one, but using ship. And I'm going to do it. Ship is open source, so I'm just going to come over here and actually I'm going to do Prometheus, I think, just to make it a little bit more complicated. So ship takes 3 commands, says init, watch, and update. So I can say ship init and just point it to any upstream that I want to. So I'll just go GitHub, Helm, charts, stable. Prometheus. And what ship does here is it'll download that Helm chart, it downloads it, determines the application type. Once it downloads it, it looks for a file called ship.yaml inside the repo. If it exists, it will have a custom lifecycle that it can follow. So it downloaded the Helm chart. It determined that it was a Helm chart. It generated a default lifecycle because the Prometheus Helm chart doesn't have any support for ship built into it right now. And then this is the init flow. So this is that very manual process that you're going to go through. What we actually do is we open up a web browser, and we'll show stuff like the README file, because the README file of a Helm chart often has a lot of good configuration information in it that you need to know to understand how to configure it. We'll continue. Helm takes a values as YAML as the context, so it's going to be passed into all the templated config. You can change it all you want to here. This is the one that I was mentioning that has 1,119 lines now. It's been a couple of days. So we'll just leave all that the same. Ship here is just turning all of that Kubernetes YAML into, or all that Helm chart into Kubernetes YAML. We show a file tree here on the left. You can look at it. You can click into them. You can view any of the YAML that you want to. I can look at this, and maybe if I want to, this is where we start to actually use Kustomize. I can click on any of this, and we'll generate a customized patch for you on the right, and I can make any change I want to. I can say I want 100 replicas of that and save that. I can also come down here and say I want to change this timeout seconds from 10 to 30 because, I don't know, maybe my environment's really slow. I can show the diff, and we actually show you a side-by-side diff of that customized patch here on the right being merged into the base. So it's not really a diff of the base and the patch, it's a diff of like the merged result that you can't actually see on the screen, what Kustomize is going to output against the actual base. And we keep the overlay down here. You can go down and you can create other ones if you want to. I can come into this service if I want to and change the type from cluster IP to load balancer. We'll hide the diff, but well, here, like the diff shows that, changes the cluster IP. Kustomize also just removed the quotes around the word server for us too, which is good because they weren't necessary. So you have all of that. You can save and continue. And it just tells you when you're done, you can just run kubectl apply rendered.yaml, and that's it. And then we exit. So we actually look at what this created on my machine. This created this file rendered YAML, and there it was, 100 replicas. So this is the output of Kustomize, running Kustomize build with my overlays against the base. We actually put all of the base that we rendered from the Helm chart in this base directory, and we create a customization YAML where we list all of the resources that are in there. We create an overlay ship directory with a customization folder or file. We reference the base, and we store just the 2 patches that you have there. So we're not doing anything that's not built into Kustomize. You could do this yourself if you wanted to. It's just operationalizing that process. We also create a ship state JSON file, which has a lot of different things in it. But one of the most interesting parts is that it has the stable SHA right here in it, and we also know like what the upstream is. The upstream came from Prometheus. So then at any point I want to, I can just come over here and say ship watch, and I'm in that directory. It's going to read that state JSON, and it's going to go start periodically polling the Prometheus chart if the internet's working for it. But it'll periodically pull that Prometheus chart and exit with a status code of 0 when there's an update available. And it didn't exit with a status code of 0 because there's not an update available. But I can run ship update at any time. And ship update's going to pull down that chart and then reapply, re-render the base, leaving all my patches separately. So again, this wouldn't have made any changes here because the Prometheus chart didn't get updated in the last couple of minutes. Yeah, and then we've taken that one step farther, and we actually made a hosted service here. So ship.replicated.com, we actually will run all this for you because that process still has a lot of moving parts, a lot of work that you have to do. So I can actually take and install a new application. I'm going to come back and actually just do the memcached one now. And you feed this in, and this is just running the ship service, the ship container in our cluster. It's actually an operator that we wrote, and we walk you through the exact same process. It's running a little bit different version of ship right now, but it is still ship. So we're going to show you set the custom values in your Helm chart, and then we're going to turn that into a base where you can apply your patches to get a deployable app. So click next. This is the values YAML for the Helm chart for memcache. Let's not make any changes to it for right now. We still show the README file over here. You click next. We'll render that all out. We're going to show you an intro to what you're going to do. It's learn a little bit about what Kustomize is here, understand what the process is. But on the left, you can see the Helm chart plus the values have been, there's a check mark. That's done. Now we have the base, and we're going to apply the patches. So we come over here. The memcache chart is much, much simpler. There's only 3 things in it. I can come into the service here and do the exact same things that I did before. Maybe I want to put the cluster IP of something static. I don't know. I can actually come into the stateful set, do the same stuff if I want to, maybe change the replicas to 500. But the thing that I want to actually do is add something new into here that I wasn't able to do with the Helm chart directly. And so what I want to do is I want to set a specific update strategy to a rolling update with a partition of 250 so that it does like a blue-green deployment. It'll only update half of that stateful set because I set 500 replicas. So I can come into here. I can just put that into there if I want to. Even though I've made all those changes, I can still come into here and make any other changes that I want to. If I want to change this image pull policy of nothing's probably not right. So I can set that to if not present, save all that, show the diff, and we can split it. The ordering of the YAML gets kind of rearranged a little bit. It becomes alphabetized, but it still shows you the diff here if you look at it. The image is, the pull policy is gone to if not present. And down here you can see my update strategies being merged in and being applied. So we'll save and continue that. And before, where ship open source kind of leaves it is you have now these files on your file system. You can go deploy this. But what ship cloud does is we'll let you download that rendered YAML if you want, or you can configure an integration. And if I want to configure an integration, what I can say is I want to create a pull request with that data, with that rendered YAML into a repo here. It's a repository called GitOps on my personal GitHub account. And I'm going to put it into something called memcache. And it'll create that pull request. And I can come over here and look at it. And this one was open just now. We look at it, and that's going to show the release notes from the Helm chart and the YAML. And here's my update strategy. So this is the version of memcache that I just used ship to configure. I can merge that in. The idea being that I have some automation that runs on git merge, right? And so like that will get memcache now deployed to my cluster. Whatever tool you want to use to do that. We'll come back over here to ship cloud. We'll say OK. And when I look at memcache, it says that I'm running 231 and it's updated. I can look at the application details. I can add other GitHub integrations in. I can get emails or webhook integrations if I want to like do something outside of just normal GitHub. I can see the same state JSON. It's running the exact same version. I can download the generated YAML, and I can see the history of Memcache, and it says deployed because it's merged on GitHub, and so we consider that deployed. And I see that. We're actually using this to manage agents inside our cluster right now. The Datadog agent being an example of one. We actually have a few different ones that we're using to run. Datadog, our production one right now is 2 or more versions behind. Our staging one is on 1.10.1. So you can see this one here. The different members of our team are collaborating on it to get it updated. I know that it's 2 or more versions behind. I can click this and just review the pull request that's open right now in our private repo. And I can see the last release note was, add socket path. Come down and look at the actual diff that Kustomize generated from my patches, and we have customized patches applied to the Datadog agent. And they changed a level of a log message, and they changed an image name. And if I merge that in, I'm not going to merge it in right now because it does actually deploy to our production environment. But if I merge it in, then this will just show a check mark that it's all updated. Yeah, so that's what Ship is doing today. And come back. So that's Ship, Ship Cloud. And we have 3 different versions of Ship that runs. Ship Open Source, which is what I demoed with Prometheus. Ship Cloud, just demoed that now. And Ship Enterprise, which is Ship Cloud packaged up and running behind the firewall inside your Kubernetes cluster, so you don't have to run it on our Kubernetes cluster, just because that's what we do, and because most people there's a lot of need for, maintain GitHub Enterprise and maintaining stuff there. So Ship enables like workflows, GitOps, notifications of different types. It enables today operationalizing a version of Helm v3, which is tillerless Helm. It doesn't only work with Helm. You can point that to a GitHub repo that has any just plain Kubernetes YAML in it, and it works just as well. It doesn't show a value screen, but the rest of the process is identical. And there's just no Git merge conflicts when you're using it. So like a normal workflow that you would use to deploy your own software. If you're writing your software and deploying it to Kubernetes yourself, you would have a developer who's writing the initial configuration. And they make that application YAML. They're going to commit it to GitHub, hopefully, or some SCM. And then you're going to do a code review. Somebody's going to look at the YAML, and like somebody else on the team is going to sign off, check it, say like, looks good to me. That'll get merged in. A CI process is going to pick that up, and it's going to deploy. There's a lot of different ways you can do this. You might use like GitOps and WeFlux, or you might have like custom scripts in Circle CI or Travis CI or something that's doing all this. But that's how a lot of people are deploying to Kubernetes today. Ship works into this pipeline, right? So instead of your developer writing new YAML, the upstream releases a new version. Ship detects that, and it commits it to GitHub. And then our goal is just to say, treat this now as YAML the same way you would have treated any piece of software that you wrote yourself, and get it deployed into your Kubernetes cluster. Locally. We actually don't copy the Helm chart itself down. That exists temporarily in the process, but we actually take your values, which are going to be like this is Helm, right? That you're going to take your values that you provided and feed those as input, as context into the Helm template command to render out the Kubernetes YAML. And so that YAML is probably specific to you because you probably changed some value. And so we actually only store that YAML, not the actual we never store any of the templated up Helm YAML anywhere. Great. All right, thanks.